Hey everybody, Will here, and today I'm doing a quick video to talk about how Adobe Premiere uses the GPU in video editing. And the main reason I'm doing that today is because I'm having some problems once again with my machine. If you tuned in last year, you knew that I upgraded my computer recently with a number of upgrades. It included the FX 8350 and the NVIDIA GTX 760 graphics card. It was kind of a half upgrade. It was like a $1,500 upgrade. And that is a little bit less than I normally spend building a computer. I think I usually try to spend around $2,000 to $3,000, which is really what gets you in the sweet spot in terms of performance for your money. But I ended up doing this kind of budget upgrade. It was inspired by my how to build a computer for video editing guide that I did last year as well, which included the FX 9590. And again, I just didn't have the $2,000 or $3,000 to do my own upgrade last year. And so I did that half upgrade. And yeah, I'm still having problems now. It's just too, slow is what it is. It works, it does what I need to do, but it's just slow. There's a lot of things that I could be doing faster. And one of the big comments that I actually got on my guide last year is that it's all about the GPU now. I kind of recommended people spend the bulk of their money on their CPU. And while the GPU is very, very important, people are saying it's the main thing that you should be spending your money on now. And I'm not entirely sure I agree with that. And so I decided to kind of put it to the test today with the upgrade for this machine, because there's not much I can upgrade without going to a whole new system, which I cannot do right now. But I decided to go ahead and do another little half upgrade to test out a few things. And that includes the GTX 780 Ti. This one is going to be one of the best GPUs you can get for video editing right now, not counting the Quadro cards, which can be thousands and thousands of dollars. Those are great if you have thousands and thousands and thousands, like more than $3,000 to build a computer for video editing. But if you're like me and you're kind of in the lower range, this is going to be about the best one you can get. To talk really quickly about how you choose graphics card for Adobe, it's going to be mostly about the memory bandwidth, which is not a number that they advertise on the box. If you go online, you can find out what a lot of gamers are choosing, what sort of frames per second you can get for different cards. But there's not a lot of great benchmarks for video editing. The GTX 760 that was in here before can be had for about $150. It was a little bit more when I got it. And that has 192 gigabits per second for the memory bandwidth, and this one has 336.5 gigabits per second. And that card's about $400, and there are newer cards, like they're up to the 900 series now, as opposed to the 700. And the kind of cards to get now are like the Titan Black and the GTX 980 Ti, but those share about the same memory bandwidth. There's not a big jump, like the jump between 192 and 336 is pretty big. I actually think the 980 Ti is a little bit less than this one. So this is going to be about the best deal you're going to find for a video editing GPU. And yeah, I wanted to test it, and so I'm going to show you some of that test right now. In it right now is the 980 Ti. I already did all of these tests with the 760 and basically went over it, made notes about what the processor was doing, what the GPU was doing, and I'm going to show you that again now and tell you how it improved over the 760 versus what's in it now, the 780. The thing that is kind of bugging me the most with the process right now is going to be basically just scrolling through footage, actually. Just for instance, this is Inspire 4K footage. I record everything, from takeoff to landing, kind of like I did with my Phantom 3. I don't like to stop and start recording in the air. So it requires a lot of kind of scanning through it, and you kind of have to see the details, not only in the framing, but also the movement. That's what's important with the drone footage. A lot of times, not so much with the Inspire, but with the Phantom 2 or Phantom 1, I'll look for the footage, and if I don't see every frame, there might be some jello, there might be some shakiness, and so you really have to see it as smoothly as you can. And if I play it right now, first of all, let me show you this resolution option here. Full resolution is going to be 4K, and I don't have any 4K monitors, so I see absolutely no difference from when it was on half just a second ago. But just to draw your attention really quickly, I have these monitors up here that I'll bring down. You can see the GPU is using about 37% of its power making this happen, and you can see the CPU is sitting at about 40%. That's at full resolution. Let's go ahead and drop it down to half resolution and do the same thing. And now you'll see that the GPU is only going at about 11%. and the CPU is still at about the same. Every single time when you start and stop something, it kind of has a moment of getting set up and getting ready, and the CPU and the GPU will jump up pretty high. The CPU longer than the GPU. It'll be up at like 80% for a few seconds. But once it settles down, you can see it's still at about 34%, which is about the same, versus now 11% on the GPU. And so likewise, I'm going to go one more time down to quarter resolution. Essentially, I'm going to be looking at 720p now here, which is, you definitely see a difference there. But it's still very watchable. And now you can see the GPU load is at about 8%, and the CPU load is still at about 30%. So the CPU is pretty much unchanged by the resolution. And if I go to a quarter or eighth, that just looks terrible. Even in 4K, I can't imagine what it would look in 1080p footage. Let's go back up to half, because that's, again, full resolution for me. And yeah, you can see the GPU is pretty much changing based on the resolution. And that's going to be the same with the older graphics card too, and the CPU is staying at about the same. Where the CPU comes into play now with this situation is if I start to play with the speed. So as I speed up, you can see it jumps up a little bit, but then the GPU settles right back down at 11%, and this is at 2x speed. And now the CPU is a bit higher. It's leveling off at around 60%. So the GPU wasn't really changed here. It's still relying on the GPU in the same amount. It's just relying on the CPU a little bit more. And then if I go ahead and go to 4x, you're going to see that it's still playing it pretty smooth for a bit. There we go. We started to lose the frames. And the GPU was the same. It was at 11 before it dropped down to about 0 when it started dropping frames. And so let's go back and do that one more time. Yeah, go to that, see 20%. Still GPU is about 20%, then it goes down to 0. And so what's happening, I think, is actually the CPU ends up, as you start increasing the speed, we could probably go a little bit longer if we drop it down to a quarter. Actually, that's not really even that. It's only a little bit true. Yeah, see, it'll still drop it, because to scroll through it at faster than 1x speed is requiring the CPU and not the GPU. So in this case, the graphics card helped a teeny bit. You can see the numbers. I did this test on all the different speed, on all the different resolutions. The 4K footage for the GoPro, for the GH4, and the Inspire were all about the same, by the way. But you can see the GPU is pretty much determined its use by the resolution, and the CPU is determined by the playback speed. Overall, the percentage of the GPU used for the 760 was higher than the 780, but that's just because the 780 is more powerful. So it's like, if you have a much more powerful engine, it's not going to be having to try as hard to move the same amount of stuff. So for this, unfortunately, even though this was my biggest frustration, I really wasn't helped out here almost at all. There was a couple marginal things where it held on to the GPU a little bit longer before dropping it and dropping those frames, but for the most part, the GPU did not really help me here beyond it already helping me with the 760. Again, the 760 wasn't a bad card, it was a great card, and it's still a very good card. I'd recommend a lot of people get it, especially if they're in the $1,500 price range, and maybe even closer to $2,000 price range. And the 780 Ti is probably overkill for you based on this test alone. If we move over, the main thing that the GPU is supposed to help with, according to Adobe, and by the way, I'm going to put a link in the video info to a page that Adobe kind of lists all the effects that are supported by their GPU, but the main thing that's going to help out with is effects. So if we go over here to our effects control, I'm going to turn everything off first to show you what we're working with. And so if I play it now, and again, this is full, so we're back up to 37% on the GPU meter. But if we go to half again, it should drop down to around 11 or 12. Let's see if it does it. I have to stop first, I think. Yep, 11, 12%. So let's go to full to make it interesting. Again, we don't have a 4K monitor, but might as well let it pretend we have a 4K monitor. And we go ahead and hit play here. So where we're at 36, 38%. And the CPU is at about 36%. So let's go ahead and turn on, first of all, Warp Stabiliser. Now, Warp Stabiliser is one that they mentioned uses GPU acceleration. I should make it a point, though, that it does not use it to analyze the footage. I pre-analyzed this footage because it takes quite a while on this system to, again, this is a few minutes, so I can do this test for you. But it does use it to play it back. So now that we play it, you can see it's a little bit higher. It's a few percent higher on the GPU, and the CPU is about the same. So you can see now we're at 42 as opposed to 38. percent. It's just using the GPU to perform that effect. The CPU, the amount you're taxing the CPU is unchanged. So that's helping out there, and let's start to layer them. Let's start to add more effects here. That's Rgb Curves, a pretty normal one to use. Now we're at about 50% GPU, and CPU is about the same, 30%, 38%, 40, maybe a teeny bit higher. But the biggest hit in performance came to the GPU. It's most taxing on the GPU. Let's go ahead and add fast color corrector. And that one didn't do too much. Still at about 51, 53. Let's go add some Sharpen there. Didn't do too much there either. Some of them, interestingly enough, like our fast color corrector, it doesn't matter what you do on fast color corrector. In fact, it doesn't even matter if you do anything. If you throw fast color corrector on, even though it's basically clear, it's not doing anything, it's going to affect your GPU performance. It's going to use the GPU to do nothing. Sharpen, on the other hand, you can throw it on there clear, and that's why I didn't do anything, is because it's at 0. Let's go ahead and play it real quick. And again, we're at 50. It was about 50%, right? Let's go ahead and just throw it up to 42. I'm not trying to make it look good right now. I'm just trying to show you the filters. And you can see now that I'm sharpening, I'm at 53%, 54%. So the more you sharpen it, the more GPU it's going to use. Again, the color corrector, you can shift the color as much as you want. It's not going to matter. It's going to use the GPU for the color corrector only. It's like one serving of color corrector. So let's drop that back to 0, or let's just get rid of it. And then lastly, we're going to add this Gaussian blur. And it's got a mask on it, so the middle isn't blurred out and just the edges are blurred out to give it kind of an interesting effect. And you can see this one is going to use a lot. It's both the blur and also when you combine it with the fact that it's got a mask on it. You can see now we're at 83% GPU. So before this, if I got rid of the Gaussian blur, the GTX 760 could handle this. If I played it a little bit faster, it might have an issue. Again, you can see the GPU does jump up when you first hit play faster, but then it settles back down. Jumping up to 2x probably would have made the GTX 6 or 760 drop out completely. And again, once you lose the GPU, you lose it completely. So let's go full speed here. See, now the GPU is not being used at all because it's just relying on the CPU that can't handle it. So yeah, the GTX 760 could probably handle this footage. I could play it at 2x, maybe, but it could not handle this. And you can see right now when I add the Gaussian blur, it's all the way up to 80% GPU performance. The GTX 760 could not handle this. So this is one upgrade that I've at least had happen thanks to the GTX 780. Motion and cropping and anything like that and rescaling is another thing that really uses the GPU too, and that's something I do a lot, like split screens. So let's really quickly go ahead and recenter that to the left. I'm going to go ahead and let's add, let's get a different scene. Yeah, there we have. Let's add another clip right there. And let's go ahead and grab some of these color effects to match it a little bit and throw it on there. And then let's go and add crop a little bit of the left, and again I want to recenter it. So this is a whole big different thing. All the effects I was adding before, the CPU is pretty much remaining unchanged, and the GPU is just going up and up and up and up. So now we have 2 streams of video, so technically it should be using a lot more CPU, and then the GPU should also be using a lot more GPU, because we've got 2 streams of video with 2 different sorts of effects, and it's also combining it into one big image, of course. And if we play that now, let's see if we can do it. So it's a teeny bit stuttery, but actually it's pretty smooth. And oh, see, it's losing it a little bit there. It lost it. I think we're going a little bit too far. Let's get rid of warp stabilizer. That didn't do too much, and I think that was what's killing it. See this, it's handling pretty well. You can see the GPU is all the way up at 98%. And both videos are, again, a little bit stuttery, but also quite smooth. I have a pretty good idea of what this image is going to look like when I'm actually done rendering, and I can still preview it. But to see this, and this is what I was looking at with the Inspire indoor flight test, by the way. I I wasn't seeing it like this. I was having to render to see anything like this. This I can do some work at and I can judge it. And you can see also the CPU is up there pretty high, 90%. I think it's going to drop down a little bit in a minute, but it's stuck pretty high up there at 100%. And so is the GPU. So this is pretty much maxing out everything right now. But again, this is a combination of filters that I could not play real time previously on the 760, and I can do it now with the 780 Ti. And you see what happens when you lose the GPU, you lose it completely. I'm 2x right now, shouldn't be able to do it for that long. Or maybe it can. Yeah, so pretty good. Definitely using the GPU there to help make that happen. The very last thing I want to talk about is going to be rendering, because that's something that the GPUs also really take advantage of. I did a test with both the GPUs. I did a test with the GTX 760, I did it with the 780 Ti, I did it with dual GPUs, and then I did it with software only. Basically, I had a few different projects with it. The first one was this quick video I'm doing with this company called Hivemapper. It's just a bunch of some aerial footage, some split screen stuff, and a little bit of After Effects too. I also did this opera recently, and it's actually like it's an opera about a medical marijuana place. It's actually pretty funny. I have no idea what they said, but it was actually rather enjoyable. And it's like an hour-long multi-camera, not a lot of effects, color correction, just a big long video. And then I did the indoor flight for the DJI Inspire, which had a lot of split screen, a lot of color. And then I also had the Phantom 1 drone reel that I did. It has a lot of warp stabilization on it, as well as a lot of color. And then I just did some Inspire footage, both Inspire footage at 1080p, downscaled from 4K with some color on it. And then I have just the Inspire footage at 4K with color on it. And then I have Inspire footage with no color at all at 4K. And so to compare really quickly, the 760 and the 780 Ti, the 780 Ti won across the board, not by a lot, definitely not worth an extra $250. You can see here the Hivemapper short 5-minute video saved me about a minute of 10 minutes. The Opera saved me, again, about a minute. Some obviously saved me more time than others, it looks like. I mean, it really was just close to about a minute all across the board. So not a huge boost there with rendering. Definitely, obviously, it helped, but not really that big of a help with the rendering. While I was watching this too, while I was watching the render and I was watching what the CPU and the GPU was doing, the GPUs were jumping up to close to 100% and jumping back down, and the CPUs were sticking at about 100%, and they were sometimes throttling down a little bit, but they were much more steady at 100%, whereas the GPUs were just bouncing up and down, but close to the top end, using 100% at times. The dual GPUs surprisingly did almost worse across the board. In a couple of instances, it did better, but for the most part, dual GPUs performed worse than even the older GPU, the 760 Ti. Just looking at the Hivemapper one, again, we were in the 10-minute range for both the 760 and the 780 Ti, and then we got 14 minutes for dual GPUs. The indoor flight test, it actually performed a little bit better, marginally better, 1 minute better. The Opera, again, an hour-long video, ended up being about the same. P1 drone reel ended up taking a couple minutes longer, of 20 minutes. And then if we go to the Inspire with color, the 4K footage with color took an extra half hour, an extra 20 minutes on the older GPU alone. And if I looked at how the GPU meters were working there, what's interesting is the 780 Ti wasn't being used in the same way. The 760 Ti kind of looked like it was being used. It was jumping up to 100% and back down and kind of doing that over and over again. The 780 Ti seemed to be throttled down to maybe match the 760 Ti. It specifically, I think, says that you don't need identical GPUs. You don't even have to tie them together with the SLI connector. They just work through the motherboard together. But you can see that the 780 Ti is not jumping up to 100% like it used to when it was rendering just by itself. But even if it's not, even if it was matching the 760 Ti, two 760 Ti's, if they were working together and using their full amount of power, should probably come in certainly not more than the 780 Ti. So that was kind of interesting to see. And while I'm on that subject, I should say I did have a 780 Ti and the 760 Ti doing all those tests I just showed you a minute ago, kind of real time working with it. And it did not use the 760 Ti at all. So yeah, Adobe's, luckily it did use the 780. I didn't have to select which one. I think it just knew which one's more powerful, and it used that one, and it just didn't touch the 760. So in my case, I took the 760 out because it does not help me at all. Having two GPUs in there, maybe. I kind of wish I could do a full test where I had two of the same card, two 780 Ti's, but I don't. But I think there's a little bit more to it than just the GPUs. Really quickly, I want to talk about the software-only renders, because I tried to do that as well. And if I throw them up on the screen here, you can see that they didn't go too well. The render test, which took about 10 minutes on the two GPUs independently, the Hive Mapper video took 2 hours and 42 minutes on software only, without using any GPU whatsoever. And then if we go to the Opera, which took about 1 hour and 22 minutes on either one of the GPUs, I had to stop at 8 hours because I couldn't wait. 8 hours and 23 minutes. I couldn't wait. I proved my point. I think you definitely need some sort of GPU acceleration if you're doing rendering, unless you want to wait. Because it does, it helps out. And I think at the end of the day, that's what's going on here. It's a very kind of complicated relationship between the CPU and the GPU. But at the end of the day, the GPU is helping the CPU. I think the CPU, kind of my earlier thing that I said, your CPU is what you want to spend the most money on. The GPU helps. But I think right now, too, with this 780 Ti, the upgrade would be better if I had a better CPU. I think even with the 760, the CPU was mostly my bottleneck. I have a little bit more performance now in certain situations now that I have the 780 Ti, but my CPU is very, very, very much my bottleneck. And when you are building a system, make sure you spend a lot more money on your CPU than your GPU, because it's just much, much more important. So I decided I'm going to go ahead and upgrade the CPU as well. Again, when I got this, a lot of people told me I should just get the 8350 instead of another 9590. We're talking about the AMD processors now, and the reason for that too is a lot of people say the 8350 is essentially just a rebranded 9590. I'll talk about this a little bit more in the very next video, but I ended up picking a 9590 up to test that very theory. I'm pretty sure it's wrong, and we're going to find out in a minute. But yeah, just to tell you really quickly, I upgraded I overclocked the CPU first of all, the 8350, and that's what people say the 8350 is, or the 9590 is just an overclocked 8350. But I upgraded my CPU, and I no way am like a great overclocker. I think a pretty good overclocker. I think I can expect to be as good as most of the people I'm advising here. But I was able to overclock it to 4.6 gigahertz, and that is actually less than this stock. This is 4.7 gigahertz stock. I started running into major heat issues, and if you watch this video and you're paying attention, you'll know that this was way hotter than it should have been. I overclocked it in the fall. It was a lot cooler, and I made it so under complete load it wasn't going over 70 degrees. I think it was approaching 80 degrees here. It was like 10 degrees over what it should be at least here. And that could damage your CPU. Don't do that. I kind of let it ride it though, because I knew this was coming. But yeah, right now I was only able to get it up to 4.6 gigahertz, the 8350, which is allegedly just a 9590. And I'm going to pop this in stock. It should run at 4.7 gigahertz, which is faster. And so we're going to start to raise my bottleneck now. And hopefully I'll be able to overclock it quite a bit more, and then we're going to run those tests again and see how that plays out. So that is coming up next, and that's the end of this video. Thanks for watching.